Okay, so today we'll be taking a look at derivatives of sums and products. The rule itself is quite simple and it's not too complicated to follow. Reads as follows. If you have some function f of x and g of x, and you take the sum or the difference here, it's the sum or the difference of f of x or g of x, and you call that new function h of x, then h prime of x is just simply f prime plus minus g prime. Or if you, this is prime notation. Or if you like, this is the Leibniz notation, if you like that. The derivative of h of x with respect to x is just simply the derivative of f of x plus minus the derivative of g of x. It's a simple rule. It's quite self-explanatory. If you want to take the derivative of a sum or a difference, of functions, you simply differentiate each function independently. You just differentiate each function independently. And here's a fun fact. It's one of the two reasons why we say that the derivative is actually a linear operator. It's just a fact if you're going to study something like linear algebra in the near future. So let's take a look at some of these problems and see how we would go about solving them. So we want to differentiate g of x. So let's say, what's g prime of x? Well, g prime of x is just simply, according to this rule, the derivative of x squared. So x squared prime plus 2x prime plus 3 prime. And these are simple derivatives. We know how to calculate them. This is just 2x plus 2. The derivative of a constant is 0. Question number 2. If we want, now I'll switch over to Leibniz notation. Just preference, again. If we want the derivative of capital F of x here, again, it's just the derivative of a third x cubed plus the derivative of 218 x squared plus the derivative of 2x plus the derivative of 3. That's just simply going to be 3 over 3 x squared plus 218 times 2x plus 2. Again, remember this goes to 0. Derivative of a constant is 0. And this simplifies to 2x squared plus here we have 436x plus 2. Question number 3, if we have here h of x is equal to sine squared of x, we want to differentiate it. So if we want the derivative here of h of x, again, it's the derivative of sine squared x. What's the derivative of cosine cubed x? Here, usually I prefer to rewrite this as sine x all squared plus the derivative of cosine x all cubed. And so we know this is 2 sine x differentiate the inside. This is using the chain rule. Cos plus 3 cos squared x derivative of cosine is minus sine. And so this is 2 sine x cos x. If you want to simplify it, that's the most you can do. And the last one is the derivative of t of x. And again, the rule, self-explanatory. It's the derivative of 3x cubed plus the derivative of 2 over x squared, derivative of 2x plus the derivative of root 2. And I'll let you complete the rest. Hint, again, remember 1 over x is also equal to x to the minus 1. Okay, and that is basically the rule. If you want to take the derivative of a sum or difference of a set of functions, just differentiate them each separately. Okay, that's all.